Good evening. Right now I'm going to talk about our assignment. We are group 5 from TT8L. I'm Go. So we are going to compile the game. We can compile it using the make command, and then we'll compile. Then we can start the server using /server. Then we will start the server. We can start the client by using /client. We'll start free client for this demo. Then it will get to the not ready state. Then you can enter to get ready. When everyone is in the ready state, the game will start automatically. Right, so for player one, you can select target player by selecting one. Then you can select a target player. We'll select player two for this case, and then we'll type in the wrong number. Then it will show zero correct position and zero correct digit. So let's say we'll target player three, and then we can guess a number that's similar but not the right number. Then we'll say that it is three correct position but zero digit right. So when it is player two, we will try to guess player one. No, we will try to see the logs. Then you can see the logs over here. Then you can target player one. You will select the right number, and it will show that player one is eliminated. For my part, what I did was I'm in charge of the client. For example, the UI design and the alive and dead UI, and then
Game logic.
the game logic. Right now I'm gonna pass it to my teammates for more details.
Okay, my name is Amri Hilman, and for my part, I'm just gonna explain it briefly and quickly. My part is for the logging part on the game log and the scoring for after the end of the game. Can you show the game log first on the back? So if you see on the left side is the logging part for our assignment. The scores part will only be available after we end the game. So before we end the game, I'm gonna pass the explanation to my other two teammates. So Harin.
So my name is Harin, and I was responsible to do the client networking part. So I use the multi-threading by creating a listener thread where it creates a parallel pipeline. The main thread handles the typing while the listener thread handles the network data. And also implemented mutex log using UI underscore mutex. And lastly, I just did the networking by using the condition variable name net underscore code. So that's all my part. My part is just to make sure the game doesn't freeze and it runs smoothly. So I'll pass it to my next teammate.
Okay, so my name is Adam, and I am responsible for the server core. So it's focused on a hybrid concurrency model. And well, to ensure stability, I used fork to give each player their own isolated processes, while also keeping the scheduler and logger as lightweight threads. The main challenge was communication, so I implemented POSIX shared memory. Now this will act as a central hub for the game state. Um, and the data is secured using a process shared mutex. And this is initialized with the pthread underscore process shared attribute. So that this guarantees that even with multiple independent processes, we never get race conditions. And I also added a signal handler to automatically reap zombie processes to keep the server clean. Yeah, that's pretty much it.
Okay, so now Weijing, can you show the end game screen right now? And then just complete the game. Okay. Alright, as you can see, that's the end game screen of our project. And then can you go to the background and show us the score? Okay, for that one, you can see that the player 2 has won and it updated on the server. So that's it from us from group 5. Thank you, madam.
Thank you, madam.
Alright, I'm Go Jing. So right now I'm going to talk about my contribution in this assignment. So first of all, my contribution is the UI design. So for the design of this, I designed the game and then the UI to make sure that it works properly in the terminal. So this is the display game UI, and then this is the your turn UI, not your turn UI, and this is your eliminated UI. and then this is your winner UI, and then this is the thanks for playing UI, and then this is the display lobby UI, and this is the queuing design, the where you need to make a state to ready, and then yep, that's all for the UI part, and then I will explain my other part, round robin. So in server.c, uh, then this is the part where it is this is the part where it's designed to queue the player and to dequeue the player. This is to check the first player. This is to check the front player of the queue, and then we use this a circular queue. So it will just keep going endlessly. Then it can go after the next player. And then you can see over in uh, over here. So if it will check if the game is running over here, then if it will check the player if it is active, and then if after the guessing game, you will dequeue the player from the front, and then you will queue it again to the back of the game. And then if the player was eliminated during turn, it will dequeue the player, so it won't just keep queuing the same player where when it is already eliminated. And then this is the part where if the player is inactive, it will dequeue the player over here. Alright, so right now we're going to talk about the client handler. This is the part where it checks if the player is handled. Then this is the part where it proves the connection works, and then it will show the secret code to the player. This is the code it will create from the server. And then it will keep listening to both messages. It will check the start and then the guesses. Then over here it will see the ready command. And if everyone is ready, it will start the game. And this is the confirmation. It will check the ready or started already ready. Then it will parse the guesser ID to the client. Then it will log the guess, and then if every correct position is selected, it will eliminate target over here. And then this is the printf where it will eliminate the player. And then it will remove the eliminated player from the queue turn over here. Then it will make the game again without the eliminated player. So like it will just remove the eliminated player without making it queuing back again. And then this is I did a little bit of this part with Amiro Human. So I think I will let him explain. And this is the part where it send responses to the client. Then it will increase the game guess counter for the turn.
Hello, madam. My name is Amri Hilman, and I'm going to continue on where I left off before. So for my part, I did the scoring system and the logging as I said before. So for this one, I'm going to explain my part of the code, the function scores.create. This function scores.create is called when the server starts. It checks whether the scores.txt already exist. And if the file doesn't exist, it automatically creates it and initializes all player scores to 0. As you can see, if the file exists, it reads the previous scores and loads them into shared memory. This ensures that player wins are not lost between game sessions. So for the next function, static void score save. Next one, I implemented a safe score saving using a temporary file approach. This function score save writes update scores into scores.temporary. This one. Once writing is completed successfully, the file is renamed to scores.txt. This prevents data corruption if the server crashes during a writing operation. As you can see, this is our scores.txt. Okay, nice. So for the next one, score the increment for this function is called when the game ends. This one. It identifies the last active player as the winner. The winner score is increased by 1, as you can see. And this update is projected by mutex to avoid the race condition. This updated score is saved is then saved immediately to the disk. Okay, for the next one, the logger threader. Okay. To handle logging efficiently, I implemented a dedicated logger thread. This thread continuously monitors the shared log buffer. As you can see here, thread was already logged, and when a new guest appears, it writes them to game.log right here. Each entry includes a timestamp for traceability. Right here, as you can see. No. I think it's this one. This design avoids blocking the main game logic and improves performance. Okay, for the last part, the void cleanup handler. This function is I added scoring persistence during shutdown. In this one, in the signal handler or the function cleanup handler, is called before the server exits. This guarantees that no game results are lost when the server is terminated. That's it, madam, for me.
Hi, madam. My name is Harin. So I was responsible for the client and working part of this game created by my group. So firstly, I created the multi-threading part for this game where I created a listener thread using the pthread create function. So this listener thread will work as the parallel pipeline for the main thread, where the main thread collects the player data, and this listener thread will collect the messages from the server while running as in the background. So as we can see here, the line 72 is my part. And I also implemented mutex log. So since I have two threads running, so this mutex log ensures one thread to run at a time. So as we can see here, the line 84 is one of the line of my mutex log. And apart from that, I also used TCP socket for the socket connections. And I created a variable called net underscore condition. Okay, for this line here has the variable called net underscore code. So this variable makes sure that the main thread doesn't have to constantly wait for the player to guess the numbers, and it only works when it receives the message from the listener thread. So my part was to make sure the game runs smoothly and it doesn't freeze or crash while playing the game. And I think that is all for my part. Thank you.
Hi, I'm Adam, and I'll be telling you in detail about the server core and how I built it. Okay, so over here we start in VS Code. Here this is server.c. Now the hybrid model combines multiprocessing for client isolation and multi-threading for internal server tasks. So let me show you how I built the engine. Now as you can see here, SHM open and mmap. So first the memory architecture, since I am using processes, they don't share memory by default. So I use POSIX shared memory to create a mapped region that holds the entire game state. Now this will act as the central brain, so all the processes can write and read to. Okay, now this is the most important, the pthread mute, I cannot pronounce that, set pshare. So this is to ensure that there are no race conditions. I initialized the process shared mutex, so notice this attribute here, pthread process shared. Now this is critical, it ensures that the lock works across different processes. So not just threads, but it also guarantees data safety. Okay, now look at this. This is pthread create. So for the server's internal jobs, I use pthreads. Here you can see I'm spawning a scheduler thread and a logger thread. These run in the background of the parent process to manage the game flow. Okay, now let me just demonstrate a real-time demonstration. Now I use the bake file to link the pthread and real-time libraries. Now if I type make, so you can see it compiles. So now I'll start the server. As you can see here, scheduler initialized, a logger initialized. So this proves our multi-threading is active. Now let me just simulate a client connecting. So over here, client. Now let me switch back to server. terminal. So as you can see here, it displays new player connected. So this proves that fork has been successfully executed. So let me go back to the server file. I will show you the last thing, which is that I implemented a sick child handler. So what this does is that it finds these zombie processes and disconnects them. So basically when a player disconnects, it reaps the zombie processes, so it frees up system resources. So in summary, I've successfully established the hybrid infrastructure including fork threads, shared memory, IPC safety. So yeah, this allows the rest of the team to build the game on top. Thank you.